Hey friends, welcome back. In the last video we left off on step number 4. So we finished right here on end of step 4. And in this video we're going to continue from step 5. And this is what we had before we left off. Basically we have the timing board complete on the bottom. And on top of the timing board we have the memory board. And only a couple of components have been populated so far. I just want to mention that the boards are still available for sale at callincture.com if anybody's interested. So I got the mainframe, the cursor board, timing, and memory board. Okay, so we're going to continue on step number 5 here, and here it says to add the character generator, but first we want to check the voltages on the character generator pins here. But before we actually do that, let's go ahead and install all the remaining passive components of the memory board. So all the resistors, all the capacitors, the remaining diodes that we have to install, I think the 1N914s, and also any jumpers that we missed. I think I might have gotten all the jumpers, but if we missed any, we'll install those too. And also the IC sockets. So I'm going to go ahead and remove this board from the stack, and we can start adding the resistors. I'll just set this stack aside for the time being. Alright, we will reference the parts list for the memory board when installing the components. So we're going to go ahead and install all the resistors here. Alright, so I got all the resistors inserted. I haven't soldered them in yet, but I'm thinking while we're inserting these low profile resistors, might as well insert the remaining diodes. We have to insert the 1N914s, and those are the D1, D4, D5, and D6. And the way we want to insert D1, since it doesn't actually have the layout on the silk screen for this diode, but we want to orient it with this stripe side to the left side. Okay, let's go ahead and solder all these components in. Okay, we got the resistors and diodes soldered in. The next thing we can do is solder in the capacitors. And there are 8 ceramic capacitors, decoupling capacitors, 0.1 microfarads. So we'll install those first. If you look at the footprint for C8, It looks like it has 3 holes here. I think one of the holes, the middle one, is actually not being used. So we'll insert the decoupling capacitor into the left hole and the right hole, and leave the middle hole unstuffed. Okay, so we got all the decoupling capacitors installed. I remember that we already installed one of them in the previous step. I think it was C10. Next, we're going to install the electrolytic capacitors, and these have to be 100 microfarads, at least 15 volts, but I'll be using 50 volts in my case. And again, we want to make sure that we orient them correctly. Okay. The only thing that's left to do is install the IC sockets, and again we're just going to go ahead and install all of them, even if we're not going to be inserting the ICs just yet. And so for the shift registers here, I'll be using this kind of IC socket. I think this is from probably the 80s or something. I forget what the dates are, but these are not modern, that's for sure. And I'm guessing the way we orient them is where this little notch is. That's where the pin 1 would be on that side. So let's go ahead and insert these into the footprints. I think the jumper wire is a little bit too big in my case, so I'm going to move it slightly so that there's room for the IC sockets. The 24-pin socket for the character generator is also from that time period. This one is made in USA. Yeah, it's similar to the 14-pin ones. Okay, I think we finished soldering pretty much all the components except for the transistors here. One thing I forgot to mention, I actually did it off screen, but I also soldered a jumper wire for this the enable for A. So basically you have to, if you want to enable this memory board as memory A, you want to jumper from here to the second hole on the right side. The left hole is for making this the B board. I'm not sure what the protect is yet, but we'll look into that later. I also just realized that I missed C12 and C14, so I'll install those next. Now would be a good time to basically comb through the back of the board and just to check for cold solder joints or missed solder joints, and any I guess any joints that any shorts between joints. And I think I might have seen some on my side, so I'm gonna take a look and see if I can actually fix it on my side, and then I'll get back to you. Before we actually do that, let's install the C12 and C14. So these are going to be well, actually one of them is the mica capacitor. It's C12 is 680 picofarads. We'll insert this into this hole. And the other mica capacitor is C13, which is 100 picofarads. We actually installed it previously. But the C14 here is actually a decoupling capacitor, 0.1 microfarads. Alright, so I just went through the board and everything looks pretty good. Let me just trim this lead here. The only thing that I noticed, and it's actually a big issue, but it's easily resolvable, but there is a short between this pin and this trace right here. And let me just show you what I mean on the actual PCB here. So I don't know if you can see that, but there's a short between this pin here and the trace. And that's actually a mistake. I think a mistake when I made these PCBs. There shouldn't be a short here. So we need to basically cut that trace with a little knife or something to remove that short. Should be a pretty easy fix, but needs to be fixed. And there you go. I cut it on my side. Basically, just used a little knife to scrape it a little bit. And so now there's no short between these two traces. I'll try to fix this for any future PCBs that I send out. But if you received a PCB set before, I guess before I discovered this issue, you may need to resolve it yourself. Let's get back to the construction instructions. Step number 5 here. So it says to add the character generator, but it says first check the place where IC9, which is the character generator, is to go for minus 12 volt on pin 1, positive 5 volts on pin 4, and negative 5 volts on pin 12. So for us to actually check that, we have to add the board back onto the stack. And I just want to, again, warn you that whenever you work with the PCB and you add or remove boards and things like that, be sure you disconnect the high voltage power, because the traces underneath here where the high voltage comes in, they're actually open and you can get shocked. Okay, so I got the board installed. Now we need, I think I'm going to use just a wire here or something, just so we can insert into each position and test it. Alright, I'll get my voltmeter, set it to 20 volts. The negative side, I'll just insert it into here. And now we can power it on. Okay, no smoke, which is good. Let's check the voltages. So pin 1 on negative, so pin 1 is negative 12. Let's see if that's actually the case. Okay, we're seeing negative 13. It might be okay. We'll see. Pin 24, positive 5 volts. 4.8, that's pretty close. And minus 5 volts on pin 12. Minus 5.9. I think that's reasonable. Okay, so I think it's within limits. So I'll just power it off for now. Let's see what else it says here. Add pull-up and pull-down resistors and solder IC9 in place. So we already installed all the resistors. We got that part finished. And then it tells us how to install the IC. It's assuming that we're actually soldering the IC directly. But since we're not, we can skip this part. Also be sure all related circuitry is in place before adding any MOS IC. Very briefly apply power. You should get a screen full of add symbols. If you don't get a screen full of add symbols, stop immediately and find out what is wrong. So yeah, let's go ahead and insert the character generator in here and see if we get anything on the screen after applying power. So these specific ICs are pretty sensitive, so make sure you are grounded when handling it. I got a gold one somewhere on eBay. I think it looks pretty cool. Alright, I got that inserted. Let me turn the TV on the side. Okay, so I'm getting static as usual with a little bit of sound. I just made the volume look a little quieter. Let's see if we can turn it on just for a little bit and see what it shows. Okay, so we're seeing add symbols. Great. I went ahead and turned it off. So Then it says once you have a screen full of ads, make up a jumper consisting of a 330 ohm resistor connected to a positive 5 volts, and briefly connect this one at a time to signal end of R45 through R50. The character should change from add to A, D, H, and P, and to blank and back again. If you get these characters, you'll probably have the rest of them as well, as we'll find out in the next step. Again, do not go beyond this point until you can display at your command at A's, D's, H, and P's and blanks. So let's see how we can actually do that. So it's telling us to use 330 ohm resistors to connect between 5 volts and signal end of R45 through R50. So right here, R45 through R50. And basically we want to connect it to pin 17 of the character generator, 18, 19, 20, 21, and 22. So basically connect these pins to positive 5 volts through a 330 ohm resistor. So let's try to do that. Okay, so this is what I made. We have a 330 ohm resistor and just a wire. So we'll insert the resistor side into 59. And now we can test the characters on the screen by shorting the pins. Shorting the pins on the character generator, 17 through 22, to positive 5 volts via resistor. So let's see what it's going to show us when we do that. Let's apply power. And we're seeing the add symbols as before. The screen is not 100% correct, and it's a little like squeezed or something. I think it's because this TV is probably messed up, and it's also wobbly. When I looked at the screen on the composite video, it was actually showing the correct image. Okay, let's short 17. Let's see if we short. So we should be getting A, D, H, and P. So let's short 17 to positive 5 volts through this resistor. A, B, I don't know why 18 is B, and then D, H, and P, and blank. Okay, let me turn the power off. Also, I don't know if you noticed this, but I ended up cutting the twin lead that's going to the TV at about 8 inches from the board, the mainframe, and then overlapped the two cut pieces over top of each other and just taped it down with some electrical tape. So the wires are not directly connected to each other, and it's basically transmitting the signal using capacitive coupling here. And this is basically to prevent direct connections, direct voltage being sent directly into the TV typewriter. It's safer that way. I went ahead and did a test by shorting the pins on the character generator, and I believe the article is actually in error here because it doesn't actually include the B there, and it should be showing a B. So basically it should be A, B, D, H, P blank. So for example, pin 17 should be A, and then B, D, H, P, and then blank. Based on the data sheet, that appears to be the correct character. So I think this construction manual is slightly wrong here in that it doesn't even include the B letter. So I think we're okay there. So now that we have the character generator working, or at least it appears to be working, it's outputting well-formed characters, even though they're not exactly as the manual has it outlined, which I think is actually a mistake on the manual side. But if we have issues with it later because of this error, we can go back and try to fix it. But I think for the time being, I'm satisfied with the results. So we can go ahead and install the remaining parts of the memory board, except for the shift registers. And really that's the only thing that's left, I think, are the transistors, Q1 and Q2. And these are the 21, I mean, it's actually 2N, 5139, both of them. And they can be oriented with the same orientation as the silk screen. Just basically try to align the transistor with the same way that the silk screen has it aligned. Alright, then we can insert the ICs. And let's see, IC7 is 7406. And IC7 is actually located right over here. So 7406 goes there. Just want to make sure we orient it correctly. And IC8 is a 2518. And this is also a shift register. All right. Let's go ahead and insert it back onto the stack here and do some more testing. So we got it all stacked on top of each other. On instruction number 6 here, we want to check the line register. And basically the way we want to check is to see if that shift register is actually working properly. And we can test it basically to see if it's actually passing data through it, and it's basically recirculating through the shift register, which is 2518. I think it's a Signetics, if I'm not mistaken. And we can basically run 5 volts to pins 9 through 14 on the bus. And it will give us the same characters as before. So let's try to do that now. I'm going to power on the TV typewriter. We're getting the @ symbols as before, which is good. And now if I connected 5 volts, which by the way is using the 330 ohm resistor that's connected to pin 59, which is 5 volts, I'll connect the other into pin 9 of the bus. And we get A as before, which is good. What about pin 10? B, D, should be H and P. And a blank. Okay, so that's good. We can check that off the list. For the next test, outline in the instruction steps here, we want to jumper certain positions on the timing board. And I actually had the timing board as the first board here in the stack. I went ahead and swapped them around so that the memory board is on the bottom and the timing is on top, in order for us to access these timing, I guess, positions, A through U, I believe. That's actually one thing I don't like, is that we have to keep on swapping the boards around for this test, unfortunately. But what we want to do next is connect to, let's say, take this little 330 ohm wire, insert the resistor side of it, or any side of it, I guess, it doesn't matter, into pin 9 of the bus. And then we will connect it to the clock positions here on the timing board, one at a time, to see what it shows. So so the TV's on already. Let me turn on the TV typewriter and do some testing. All right, so we're getting all @ symbols. Now I will connect to B1, which is pin 9 of the bus, to R on the timing board. And R is right here towards the back. And we should get A's, so half ats and half blanks on the screen. I'm getting A's for some reason. What if I connect to Q? The Q clock should give you 2 stripes of ats, 4 rows per stripe. Yep, looks about right. What about P? The P clock should give you 4 stripes of ats, alternating 2 rows per stripe. Okay, that looks correct. What about O? And the O clock should alternate rows at of ats and blanks, one row each. So it looks correct to me. The only thing is that it's not showing me blanks, but instead it's showing me A's. So the ats are correct, but the A should be blanks according to the document here. So the other ones, the J, K, L, M, and N, should not change anything according to the document. Well, I'm seeing J, K is not changing, M is not changing, and N is not changing. Oh, maybe, oh, hold on, that's probably not the J, this is the J. Okay, yeah, I was connecting it to the wrong one. And L. Okay, so it's not changing anything. We're just seeing all that still. But the I clock should turn the right half of the screen blank. So let's connect it to the I clock. Again, it's doing the correct thing. The only thing is that the screen is showing A's instead of blanks. Similarly, the H clock should give you 2 vertical stripes. Okay. The G4 and F8. So let's do G. Okay, so that's 4 for G, and F should be 8. That's correct. D, C, B, and A clock should do nothing. So B. Oh no, B's. No wait, that's D. Oh, I guess it's supposed to be giving me blanks. What about C? C is not doing anything. Oh no, that was actually G. What about A? Yeah, again, A is giving me blanks. If these tests are okay, the line register is probably working properly. If not, double check for line clock, line 1 transfer, proper connections, etc. Well, it looks like some of these clocks are slightly off based on what is displaying on the screen, which we can probably investigate further. But I want to actually continue and do something quickly just to see what result we're going to get. By the way, I think the character difference might be related to the character generator. It might just be a slight modification from the standard 2513 character generator, but we'll look into that later. Okay, so reconnect B6 line to, I guess we have to connect the B lines to a different clock, and we're supposed to, once we connect it to the correct clock, we should get the entire alphabet, numbers and punctuation spelled out, repeating every 2 lines. So let's try to do that with 6 jumper wires like these. I made a couple more of these jumper wires with a 330 ohm resistor, and I connected them as outlined in the instructions. Basically, B6 is supposed to be connected to the O clock, and B5 to the I clock, B4 to H, B3 to G, B2 to F, and B1 to E. And now, if we turn on the TV typewriter, what we should be able to see is basically the entire alphabet and characters, special characters, and let's see what else. Punctuation. So yeah, numbers and punctuation should be spelled out, repeating every 2 lines. So let's see if we actually get that. Let's turn the TV typewriter on. Alright, so we're seeing ABC and then @ symbol ABC, HIJK, HIJK, PQRS, PQRS, XYZ. And it's also flickering for some reason. I wonder why. I wonder if I can maybe adjust the clock or something. Keep it from flickering. I don't know why it's doing that. Capacitor that I attached to the crystal oscillator got disconnected. Okay, so I made some adjustments and it's still a little wavy, and I think it's the TV's problem, but now it's a lot steadier. It's also a little bit cut off here too. Might need to adjust the TV for that. But yeah, we're seeing some characters, and it looks like, so yeah, we're seeing special characters in 0, 1, 2, 3, 4, 1, 2, 3, 0, 1, 2, 3, 89. So it looks like it's repeating characters instead of showing us the full alphabet, which is interesting. Need to figure out why. So I took another look at the jumpers here that I had connected, and it looks like I had connected the B3 jumper to the B position by accident instead of the G position, because they're right beside each other. And that's why we were seeing some weird results there. But now that I have it connected into the right position, it looks like we're getting the alphabet. So we get A, B, C, D, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. And then we're seeing a bunch of characters and the numbers. So that's actually a positive sign. That's great. So that circuitry is great. The one thing that I don't really like, and I think it's still the TV's problem, but the image is just like squashed a little bit, and it's a little wavy too. So yeah, I think it might be the TV issue. I don't have another TV that has controls for the vertical and horizontal position and the sizes of it, so I'm gonna have to stick with this one. Okay, so I think we're in a good position. We can move on to the next step, but we'll save that for the next video. And so in this video, we completed the memory board, populated it, and tested to make sure that the characters show up correctly on the screen, and we get the full alphabet now, which is awesome. Thank you for watching this video, and I'll see you in the next one, in which we'll be assembling the cursor board and also add the shift registers to the memory board.